Hello everyone, welcome to Hightech Study Plus. In today's video, we are going to discuss something more about motion in a straight line. So let us begin. Our first concept is average velocity and average speed. Average velocity represented by v bar is given by the change in position or displacement divided by the time interval. I can write v bar is equal to x2 minus x1 divided by t2 minus t1, which is equal to del x by del t, where x1 and x2 are the position of the body at time t1 and t2 respectively. The SI unit of average velocity is meter per second and it is a vector quantity. It requires both magnitude and direction for its specification. Now let us discuss the xt graph or the position time graph. In this first case, we see that the displacement of the body is increasing with time. So it is undergoing a uniform motion and the body has a constant velocity. Now the second graph represents the opposite of the first graph. Velocity of the body is decreasing at a constant rate, or we can say that the object has negative velocity. In the third graph, we observe that the position of the body does not change, and if the position of the body does not change, it has zero velocity. It does not move at all. It is at rest. Now let us discuss about average speed. Average velocity is equal to displacement by time taken, and average speed is equal to the total path length divided by the time taken. It is a scalar quantity. It requires only magnitude for its specification. It has no direction at all. And if the motion of an object is along a straight line and in the same direction, that is, let us consider this object, it is moving in this direction, the displacement of the body will be equal to its path length or distance, and the average speed will be equal to v bar. So if the motion of an object is along a straight line and in the same path, then the displacement is equal to path length and average speed is equal to average velocity. Speed is positive, whereas velocity, being a vector quantity, can be positive, negative or zero. Therefore, speed is always greater than or equal to velocity. Now let us discuss about instantaneous velocity and speed. We know that v bar is equal to del x by del t. Now, instantaneous velocity or velocity at a particular instant is equal to limit delta t tends to 0. Here we are assuming that here we take the time interval delta t to be infinitesimally small, del x by del t, and we can write it as d by dt of x or dx by dt. Instantaneous speed is the magnitude of velocity. If the velocity is minus 10 km per hour, the instantaneous speed is 10 km per hour. It is always positive, so we take the magnitude only, we do not consider the signs. As speed is always greater than or equal to velocity, average speed is also greater than or equal to average velocity, because average speed is always positive, average velocity can be positive, negative or zero, and instantaneous speed is always equal to instantaneous velocity, because we are finding out the speed or velocity at a particular instant of time. Now let us discuss about acceleration. Acceleration is the rate of change of velocity. Average acceleration a bar is equal to change of velocity divided by time interval. If v1 and v2 are the velocities of the body at time t1 and t2 respectively, then change in velocity is equal to v2 minus v1 and time taken is equal to t2 minus t1. So a bar is equal to v2 minus v1 by t2 minus t1, which is equal to del v by del t. Instantaneous acceleration is equal to limit delta t tends to 0 del v by del t, which is equal to dv by dt. Now let us discuss about the xt graphs. In this case, the body is undergoing a motion in which it has a positive acceleration. In the second case, the body is undergoing a motion in which it has a negative acceleration, has constant velocity, and if the velocity is constant, the acceleration is equal to 0. Basically, we come across two kinds of graphs in this chapter, the xt graphs and the vt graphs. The slope of xt graph gives us the velocity of the body, whereas the slope of vt graph gives us the acceleration of the body. And the area under the vt graph gives us the displacement of the body. Now let us discuss about the vt graphs in case of positive acceleration and negative acceleration. In the first case, the acceleration of the body is positive and the body is moving in a positive direction. In the second case, the acceleration of the body is negative, but it is moving in the positive direction. It moves in the positive direction till t1, and from t1 to t2 it moves in the opposite direction, and the acceleration is negative. And in the fourth case, it is negative acceleration as well as the movement is in negative direction. That's all for today. Thank you.